right, today we're going to learn about analyzing data display. So pretty much a pretty easy introduction to data. So the very first thing we're going to look at is example number 1. So if we look here, it says that Miguel plans to buy a new car with the gas mileage shown. To determine if the gas mileage of the car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he researched? So you have some information here. And one thing that you notice that they do, they took the data points and they put it into a dot plot. And so what's nice about a dot plot is a dot plot's used to interpret the data. As you can see, the dot plot shows that most of the values are clustered around that 25 to 28 range. And then you have this really big outlier over here of 45. Now, what is an outlier? An outlier is something that lies outside most of the data. It isn't that it's not actually a data point, it just doesn't correlate with the other things in which you're looking at. So the car that Manuel plans to buy has about the same city fuel efficiency as comparable cars. So the purpose of this is to talk about what are some things to look at with statistical information. Well, first of all, we could look at what's called the max. The max is the highest amount. So our outlier of 45 would be considered the max of the data. Our minimum is our lowest amount. So for this information, that would be 25. Then the range is the difference between the maximum and the minimum, which is 20. Again, how did I get 20? I got 20 by subtracting 45 and 25. Then we have the mean. So if we wanted to, we could take the mean, find the mean of the data, and therefore what we do is add all the data points and divide by how many data points there really are. So if we look here, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So once you added all those values, you'd have to make sure that you are dividing by 16 for this particular situation. Then the median is what we call the middle number. When you're finding the median, you have to make sure that the data points are put in order from lowest to highest. And then you need to find the exact middle. Sometimes that will be one number, and sometimes that would be two numbers. If it's one number, then obviously your median is that value. If the median ends up being two numbers, then you have to find the average of those two numbers, unless, of course, those two numbers are the same value. We said there were 16 data points, so therefore you would need to make sure that you're looking at the two middle numbers and adding them and dividing by 2 to find the actual median. And then the last is the mode. The mode is the one that's used most often. In a data plot, or dot plot, mode can be more than one number, and it can be no numbers. In this particular case, we see it's 26 and 28. So now we're looking at another information that talks about a histogram. So therefore, our marketing team is about to launch a campaign for a new product that's targeted to adults aged 25 to 35 years. The team is researching the age range of viewers of a certain TV show to decide whether the advertising works for them. So they have information from 30 viewers below. A couple ways that we could interpret this information is one way is called a frequency table. So a frequency table would look something like this. In a frequency table, you make little ranges for the values. So we chose to use 0 to 4, 5 to 9, 10 to 15. What's important in a frequency table is that the ranges stay the same. But remember that the intervals must be consistent. So therefore, I can't go from 0 to 4 and then all of a sudden 5 to 25. Because we chose 0 to 4 as our first range, we had to follow that all the way through. Now, what do those data points represent? Well, those data points represent how often in this information above you see those values. So 0 to 14 happen twice. And we can see that by 14, and we can see that by the other 14 that is here. Now, why would we use a frequency table? Well, a frequency table is helpful because then it could create what's called a histogram. In a histogram, you can see that the values are the same. So here I have 0 to 4, just like I had in here, then 5 to 9, 10 to 14, 15 to 19, and so forth. Now, what's the difference between this and a dot plot? In the previous page, the dot plot was very specific on each individual point. Whereas you can see in a histogram, it's very generic, meaning that I don't know exactly what is in between 15 to 19 as data points, but I do know there were 10 values that there were. I can also tell there are 0 values between 0 and 4, and I can tell that there were 1 values between 35 and 39. Now, what we were looking for in this particular case was the ages 25 to 34. So as you can see, these two bars represent viewers aged 25 to 34. Not about a huge amount for this situation. As you can tell, it actually between 15 and 24, that's the higher. So therefore, if I was using advertisement for 25 to 34, this might not be the show in which I want to do so. Next, we can figure out and interpret information and try to find what's called a box plot, also known as a box and whiskers. So when we do that, the first thing we have to do is put the data in order. So I would put 25, 5, again, I'm simply taking the data that is provided above and putting it in numerical order. Because when you're doing a box plot, or also known as a box and whisker, you have to make sure that you have intervals. And the intervals have to represent the information that is given. So now that I have the information from lowest to highest, I can gather some data points that we were talking about earlier. So I know right away this is my minimum, and I know right away this is my maximum. Next, I want to be able to figure out where my median is for the set of data. In this particular case, our median happens in between these two 45s. Now, what's nice is, even though I have two numbers, I have two identical numbers. So therefore, my median is exactly 45. But another thing I have to do is create quartiles. So therefore, looking at this, I'm going to have the first section go from 25 to 45. That's considered the lower quartile. And then I'm going to have the second section start this 45 and end at 68. So what I'm going to do now is find the median of the lower quartile. And as you can see, the lower quartile, the median for that particular case, or quartile 1, would be between 32 and 32. Again, what's nice is that they're actually the same number, so no math is needed. Whereas, if you look at the upper quartile, the median happens between 50 and 58. So therefore, we would have to actually figure out what quartile 3's information would be. So I would add 50 plus 54 and divide by 2, which ends up being 104. And when I divide 104 by 2, I get 52, making my upper quartile or quartile 3 data 52. Now that I have all my information, it's time to actually create that box and whisker. I'm going to choose to go by intervals of 10 for my box and whisker. So 10, 20, 30, 40, 50, 60, and I'm going to put 70 there. So we know my minimum was 25, so I'm going to put that dot right about there. And we know my maximum was 68, so I'm going to put that dot right there again. That is 25, and that is 68. Now, I have to put my lower quartile, which is that quartile 1 information, on here. And that was 32. So I'm now going to put an actual bar, which was my Q1, which was 32. Then I had my median of the entire information, which was 45. I'll put that bar here. The median is also called quartile 2 as well. And then I'm going to put my bar that was my quartile 3, which was 52. And now it's time to connect all the information, which is where the name box and whisker comes into play. Now, what's important to understand is that in each portion of this, it's worth 25%. So this is 25% of the data, this is 25% of the data, and this is 25% of the data. And then lastly, this is 25% of the data. So what's important in a box and whisker is that each quartile represents %. But as you can see, the values in between sometimes are closer together or further away. When the values are closer together, that means the data points are therefore highly concentrated. When they are further away, like between quartile 1 and quartile 2, that means the data is not highly concentrated, therefore they're more spread apart. So, this here is talking about Helena's dance team scores 68 points at a competition. The score for all the teams that compete are shown below. Helena wants to know what place her team finished. Should she use a dot plot, a histogram, or a box plot to display the data? So what is the helpfulness of each one of these? Well, if we do the dot plot, our main focus is to show clusters. Of data and outliers. So she's looking to see if any of the information is a little outlier. That dot plot would be helpful. If she wants to use the histogram groups values into ranges / intervals. Again, making sure that they are the same. And they don't show individual points. And then lastly, if she wants to do the box plot, also known as a box and whisker, it shows center and spread, individual, just like the histogram, is not displayed. But still has the 5 key statistical points, which is your mean, your median, which is your maximum, your minimum. You can find your range, and then your different medians throughout the information. What place did Helena's team finish in the competition? The best would be to use a dot plot, and then you could be able to figure out from there what she would do. So at this point, we've gone over the 3 different things: dot plot, histogram, and box plots, and what is important from each one of those. They all have their own way of doing things, but they all do show data overall. Homework for tonight, page 470, number 12, 14 through 18. You have to do all of them, and then don't forget your exit ticket. All right, thank you.